graphing the sine and cosine function. And I know that we did this last year, and some of you might remember it, some of you may not, and that's okay. But both sine and cosine are periodic. They repeat their image every basically trip around the unit circle. And if you think about what the unit circle looks like in terms of the quadrantal angles at 0, 90, 180, 270, and 360, really you can boil down the graphs based on is it looking at the y value for sine, or is it looking at the x value for cosine? So I'm just going to go ahead and label our 4 quadrantal points, -1, 0, and 0, -1. And so if you remember, we had talked about the sine value. The sine function follows the y variable. And so I'm sure you did this and maybe even explored it on Desmos, that at 0, our y variable is 0. At pi over 2, the y variable is 1. At pi, our y variable is back to 0. At 3 pi over 2, our y variable is -1. And back to 2 pi, our y variable is 0. So, and if you think about this, as your y variable goes around the unit circle, it's increasing and decreasing very predictably, right? Very, very smoothly. So when we go to graph it, it should also be very smooth and predictable. So it comes up very nicely, very balanced, comes down, and then comes back up. So, and it shouldn't be dotted. Sorry, that's just my malfunctioning pen. And then we would get a similar image on the left, because again, of the periodic nature, as you go around the unit circle, you are looking at the same y values over and over and over. So then we'd get up to here, down to there, and back up to there, and to try to make them as smooth and rounded as possible. Now, some things about this. It has an amplitude of 1. And remember, amplitude, this idea or this term amplitude, really tells you how much do you deviate from the line of symmetry. So this being our line of symmetry, because the highest values here are 1, we have an amplitude of 1. We're going to look at some of the examples where we start putting coefficients in front, and that's going to affect the amplitude. That's going to affect how far you deviate from that line of equilibrium. But in this case, our amplitude is 1. We're also going to talk about a fundamental length or a period of the function. Because the sine takes a whole trip around the unit circle, our period will be 2 pi. Okay. Now, cosine is going to look very similar. If we follow the x variable, it's going to give us really the same image. It's just going to have a different starting point. So for cosine, the cosine of 0 is 1. So we know my graph starts there. And then as we come up, the x variable then goes to 0. And then our x variable goes to -1, right? At 180 degrees, our variable is -1. And then at 270, our x variable is back to 0. And then at 360 or 2 pi, we're back up to 1. So again, it's that same smooth curve, right? It just has the start, it has the start of our amplitude right at 1. I don't know why that part decided to come up. There you go. And then again, we can continue our graph there, and continuing to get nice and smooth. So again, the key features of the cosine graph, again, like the key features of the sine graph, are our 4 quadrantal values. So I probably should label these, although it's sort of, I think you can kind of see them. But as we start changing the period of our functions, we're going to be changing our label. How often does it hit these values? And this is amplitude of 1. And then amplitude's always positive, because again, amplitude refers to how much are you deviating from your line of symmetry. So again, kind of things to remember. The normal amplitude of sine and cosine is 1, and the fundamental period of sine and cosine is 2 pi. What we're going to start looking at is doing transformations. and adjusting things. And so I do want to go through some examples. And again, you might not remember any of it. No worries. You might remember some of it. Awesome. So feel free to pause the video and graph them on your own if you'd like. But the first one I want to look at is 4 sine of x. And looking at this 4, if you remembered, I alluded to that affects the amplitude. So instead of having an amplitude of 1, it has an amplitude of 4. So if I think about my sine graph, instead of sine of pi over 2 being 1, it's actually going to be up to 4. And then back down to 0. And then instead of -1, we go to -4 and back up to 0. So it's still the same sine wave, right? Very aesthetically pleasing, right? Very balanced. That's a great one. But our highest value is 4. Our lowest value is -4 because, again, the coefficient in front affects the amplitude. And when I'm graphing these functions, I do want 2 full periods. So I also want to balance it on this side. And that's kind of like the expectation, right? So then we go down, come back up, and down like that. So we've got our 2, right? We've got our 2 periods. And if it's 4 sine x, so we know that this is 2 pi. Nothing has changed with the period. That's 2 pi. That's 3 pi over 2. That's pi. That's pi over 2. And that's 0. When you get to the negative side, it's okay just to go every other label. That's fine. So there's 4 sine of x. Okay. If I have -3 is front, again, really the 3 determines the amplitude, but remember the negative will be a reflection. So cosine normally would have started up here at +3, but because there's a negative, we're actually going to start down at -3. So 1, 2, 3 right there. So cosine of, again, filling in your quadrantal values of 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So our cosine function, again, starts at its maximum amplitude. At 90 degrees, or pi over 2, the cosine is 0. At pi, the cosine is, it'd be -1, and then -1 times -3 is 3. 3 pi over 2 is back to 0. And then 2 pi, we've completed our first cycle. So again, our sine wave, I'll go to blue. So our sine wave, or our cosine wave, I should say, does something like this. And we want 2 full periods. So we're also going to put one here. Oops, put one here, put one here, put one here, and put one here. So we've got our 2 full periods of our cosine wave. And I promise you, I'm writing on this, it's just not responding. So, there we go. Okay. And on this side, we should, again, just label -pi and -2 pi. Okay. Now, again, last semester, we saw some similar transformations. So I'm looking at this example 3 here, that -1, that is a vertical shift. So everything is moving down 1 unit. So sometimes what I like to do is draw like a new line of equilibrium. So -1 now becomes my line of equilibrium. And from this, I'm going to make sure I have an amplitude of 3. So again, the cosine function starts at the highest amplitude because cosine of 0 is actually 1. In this case, 1 times 3 is 3. So I'm going to go 3 up from here. 1, 2, 3. And that's where my cosine function starts. And then the cosine of, again, putting our quadrantal values here, that's pi over 2, that's pi, that's 3 pi over 2, and that's 2 pi. So then we know that at pi over 2, it's 0. But remember, our 0 is the new equilibrium, right, at -1. At pi, you're down here at -3. But then it's one more down, so it's -4. At 3 pi over 2, you're at equilibrium. And at 2 pi, you're at your highest value. So again, thinking about amplitude, our amplitude is 3, which means I'm deviating 3 from that line of symmetry. So 3 up here, that takes me to 2. 3 down here, that takes me to -4. So if I think about the distance between 2 and -4, that's a distance of 6. Half that distance is 3. That's also our amplitude. So let's go ahead and complete this graph. and come down to here, come up to here, and up to there. Okay, so there's again two full periods of our cosine wave. And again, just make sure you label the negative sides, negative pi, and then negative 2 pi. Okay, so that's our first video, and then I'm going to make one more that kind of again walks through a couple other different things that happen. Um, if you remember some of this, feel free to do them and then check at the end of the video. Otherwise, work through the next one as well.